In this topic, I am going to discuss about the various GPU programming approaches that are available to program the underlying GPUs. As you can see, the approach that is available is a standard C++ and Fortran language. So, this NVIDIA has developed their own SDK compilers to develop the program for their own GPUs, and this SDK is basically based on a C++ standard. So, means it supports all the constructs and syntax of advanced C++ standard, as well as NVIDIA also has defined their own functionalities or functions in their own SDK to support their underlying GPUs. So, basically it is a very advantage of using this approach is the developer only has to modify the particular portion of the code which he wanted to offload to the GPU rather than rewriting the entire code. Second approach is a directive based programming. As the name itself is suggesting directive, so basically the directive is provided to the compiler, and compiler will identify those directives, and it finds that particular portion of the program or code is to be offloaded to the GPU. So, in this category there are two approaches. First one is a open ACC programming model, second one is a open MP programming models are available to program the underlying GPUs. Next one is the non-portable kernel based model. Such kind of kernel based programming models are developed by the manufacturer itself. As you can see, the compute unified device architecture, the programming model, which I will discuss in detail in this course, is developed by NVIDIA. They call it is CUDA. Similarly, there is another kernel based programming model, that is heterogeneous interface for portability, we call it HIP. It is developed by AMD for their own GPUs. The main challenge of such kind of kernel based programming model is that if you are developing your application using CUDA programming model, the same program will not execute on the AMD GPUs. The next programming model is the portable kernel based programming model. So, as the name itself is suggests, there is a portable, that means any application developed using such kind of models, they can easily be ported on any of the architecture or any of the GPU, whether it is Intel, AMD or CUDA. So, most popular kernel based programming model in this category is SYCL, which is widely being used. You can say Intel SYCL is available to program their GPUs. OpenCL, Cocos, these three are very popular these days, and other two is being explored and getting popularity gradually. Apart from these models, there are another category, that is a high level language support. So, apart from C or C++, if developer wants to develop their program using the Python, so they can use the libraries which directly supports the GPUs, just like CuPy, CUDF, PyCUDA and Numba. Such kind of libraries helps to develop the program for underlying GPUs. This basically supports the NVIDIA GPUs. Apart from Python, there is another language which is gaining very popular or getting popular in a computational domain. that is Julia. Julia also supports NVIDIA GPU, AMD GPU and Intel GPU. By using the supporting package, we can easily write a portable and high level program, high level applications using this language, which can be easily ported to any of the architecture. Now, I am going to discuss in detail about the CUDA programming model, and CUDA programming model is used to program the NVIDIA GPUs only. So, this programming model basically provides the ease of integration with C and C++ programming language, because C++ programming language is widely being used in developing the scientific applications for a very long time. So, CUDA developer of CUDA has taken care of this developments in C++, and they develop their own programming model in such a manner they can easily be integrated for the existing applications. It provides a rich set of libraries and tools that basically helps the developer to develop the GPU based programming easily. And another advantage of this programming model is that it allows the developer to focus on the complex problem solving rather than dealing with the low level hardware details. At the same time, the developer of CUDA is maintaining the ecosystem very effectively. As per the need of the market, they always coming up with the new libraries they are adding in their ecosystem, which can be used by the developer in development of their application. The CUDA program execution flow. So, I will this is the execution flow basically the which CUDA programs follows. So, I will explain it with some example of which I am using throughout this course, that is the addition of two array. Suppose I have two variables, two vectors, or you can say two array A and array B. So, I have to perform the addition operation of these two vectors, two arrays. So, first of all, I need to allocate some memory space for A and some space for B on the host system's memory, and if I am storing the result in another variable, just like here I am just considering it C, then I have to declare allocate the space for this variable as well. If these arrays are not initialized, then I have to initialize this array by storing some value. In case data is available, then there is no need of initialization. Once the memory is allocated and data is initialized in the host machine, it is required to allocate the same memory location for the same variables on the GPU or device. Once the allocation is done on the GPU, the data must be transferred from the host memory to the device memory. When the data will be available on the device memory, only then the kernel launch function can be performed, because every kernel will try to find its data in a device memory, means in its own memory for execution. Once the kernel is launched, execution is completed, results is generated, then that particular results again must be transferred from the host memory transferred from the device to the host memory. So, once this process is completed, the GPU is free, and then whatever the memory we have already allocated, means we have reserved for the variables, that must be released. Now, I will discuss about various other features which is supported by the CUDA in their own programming model, just like the function declaration. As you know about the function declaration is very essential to define where this function is going to execute, whether it is going to execute on the device, whether this function is going to execute on the host, or from where this function is going to call. So, for this purpose, the CUDA has defined, or you can say the CUDA is providing you some qualifiers. So, there are 5 qualifiers, but out of 5 I am going to discuss only 3 qualifiers. I am not discussing no inline and force inline qualifier, that is out of scope of this course. So, first qualifier is a global qualifier. You can see the syntax, you have to write hyphen hyphen global and hyphen hyphen. So, whenever this qualifier is used, that means we are declaring the kernel, that function will be called as a kernel, and this particular kernel will be called on the host, but execute on the device. Means CPU will call that kernel function, but actually it will going to execute on the GPU. Then you can see the example how we can declare. So, there is a very simple program I have taken for the example is hello world, hello from GPU. So, you can see this global qualifier void, and any name you can keep, your name you can provide to your own kernel or function, and within that function you can write any of your logic. So, point is to be remember, whenever I am declaring any function with the name of global, it is going to call as a kernel in CUDA programming model, and this kernel will be called on the host, but will execute on the device. Whenever I am using the word device, that means it is a GPU. Next qualifier is the device. You can see the syntax of defining the device function. Such functions will be called and executed on the device itself. Meaning is that, suppose we have only one GPU, and then there is a one function in your program which is written with a qualifier device. That means that particular single GPU is going to call this device, and the same GPU is going to execute on the device. If you have a multiple GPUs, in that scenario, one GPU can call this device function, but another GPU can execute that device function. Next one is a host qualifier. Whenever we declare any function with the host qualifier, that means this function is going to be called and execute on the host machine only. Whenever I am using the word host, that means it is a CPU, it will be executed by the CPU only. No GPU will be involved in the execution of the function which is declared by the host qualifier. Next one is a variable declaration. As you know that if you are learn some programming in C or C++ and Java, where we used to declare some variables like float, int, character, etc. Similarly, CUDA also supports several variables declaration functions, and to declare those variables, CUDA has provided some qualifiers, and this qualifiers is basically indicating the presence of that particular variable, like whether that variable will be on CPU or it will be on GPU's memory or on both. So, let us discuss the first qualifier. So, do not get confused with the device qualifier. The same device qualifier I have used in a function declaration. Here you can see the same qualifier I am using to declare the variable. The difference is that how you are applying this device qualifier. So, in this example you can see that I have used the device qualifier to define the one variable of int type. So, whenever you define any qualifier variable with the name of with the qualifier device, so it tells that variable will be in a global memory and it will be accessible from all the threads with a lifetime of the application. Meaning is that when application is executing till the end of the life of application, all the threads can access that particular variable. Next qualifier is the constant. Whenever we declare any variable with the constant qualifier, that variable will be declared in the constant memory, and this constant variable or value of this variable, it will be accessible from all the threads with the lifetime of the application. Next qualifier is the shared. When any variable is declared with the shared variables, that means this variable will be present in the shared memory of that particular block. So, whenever any block will be launched on the particular SM, so whatever the shared memory will be provided to that particular block, and this variable will be available there, and this variable will be accessible from all the threads within a block only, and the lifetime of this variable will be the lifetime of the block. Means that till the time the block is alive on SM, this variable will be alive. Once the block is complete its operation, it went out or it you can say that if it is operation is completed for that particular block, then this variable will also vanish. Next one is the restrict qualifier. It is a standard C definition and it indicates that pointers or should not be aliased. Meaning is that no other pointer will reference the same memory location if we have declared any variable with the name with the qualifier restrict. So, you can see the example section. Here we have declared one variable A with a restrict qualifier and variable B also restrict qualifier and variable C with a restrict qualifier. So, meaning is that this locations which is reserved for these variables will not be alias and will not be used by the other. Next one is a managed qualifier. This qualifier declares a variable, and this such kind of variables can be accessed by both host and device. So, we will discuss in detail about the managed variables in a unified memory section. Next is a vector types. CUDA programming model supports several vector types, and it is very powerful vector types, because it helps to keep the real life variables in its variable, and it supports like 1 element vector, 2 element vector, 3 element vector and 4 element vector. So, what is the meaning of the 1 element, 2 element, 3 element and 4 element vector? If you see any real life problem, so real life problem and the data associated with that problem can be a 1 dimensional, can be a 2 dimensional, can be a 3 dimensional, or it can be a 4 dimensional. To give you the better understanding, so I will discuss about the 2D element vector with some example. Suppose we have a 2D plot, it is represented by x, it is represented by y, and there is a one dot, there are several dots are there, and somebody or developer wants to store the position of this dots in a single variable. We can developer wants to make, so he can declare one variable like ax or bx, or you can say the other variables cx or dx. So, thing is that suppose you are considering this dot, and with this dot there are two values are associated with that. So, one is in x direction and another one is y direction. So, you can define two variables for this particular dot, and we can keep the data of its coordinates. Otherwise, we can use the 2D vector element functionality, where I can declare the float 2 type of vector and a single variable I can keep the two values. Whenever I am using this, so what is going to happen, these two elements means x and y coordinates with respect to one variable, I will give the name it to A is the one dot point name, and its value of x 1.2 or 3.2 whatever will be stored in a consecutive memory location. So, memory accessing will improve. In simple terms, I would like to say that it helps the developer to group the multiple values with respect to any object can be stored in a single variable. Similarly, if we consider 3D vector element, and we want to understand what is the use of 3D vector element. Suppose somebody is flying a kite at particular time, he wanted to know the position of the kite. So, kite is flying in an open space. So, that means the three variables are associated with that x, y and z. So, means the position of kite, there is an object and the value associated with that is the 3 coordinates value x, y and z. So, by using the float 3, because 3 is indicating how many values it can store related to the particular object. So, in that scenario the kite position values of x, y and z can be stored in a single variable, and in terms of memory all these 3 values related to the position of the kite can be stored in a consecutive memory location. So, this is a feature. So, means programmer can focus more on developing the logic rather than thinking how he can store and manage the data in memory locations to improve the performance of the machine. Next is a 4 element vector. So, 4 element vector where it should be used. Suppose we have taken one object, that is a circle, and in this object you are filling some color. Whenever we are filling some color to it, so it is always R, G and B, 3 colors. But I can add one more parameter to each color, that is alpha. The alpha is basically indicating the transparency of the each color. So, meaning is that the object has a one color and the color of that object has a 4 values. One is R, second is G, third is B and last one, fourth value that associated with that color is alpha, that is related to the transparency. So, with the help of such kind of 4 element vector, the 4 values can be stored in the variable which is declared with the help of float 4. So, in a simple terms we simply can say, if I am using the float 1 and I am declaring any variable like vector 1d. So, this variable is going to store only one value. If I am declaring the vector with the help of float 2, the vector name is vec2d, you can give any name. So, this vector I can store 2 values, variable is 1, but I can store 2 values. If I am declaring the vector vec3d float 3, so this vector can have 3 values, similarly for vector 4 float 4. So, basically this numbers is indicating the how many values we can store in the variable declared with this vector type. Now, dim3. dim3 is a special vector type which is used in CUDA to represent 3 dimensions. You can see the number here 3. So, 3 is indicating the 3 dimensions itself. It will indicate if any variable we declare with this, that variable can have 1 value, 2 value or 3 value, but maximum 3 values can be provided to that particular variable which is defined with the dim3. So, here you can see that dim3 is a vector type, blocks 1d is a name of the variable and here I am declaring only one value. So, that means this variable can store only 5, one value is 5 values. So, that means you can say it is a one directional, one dimension. If you are using a variable and you are declaring block 2d, because you are declaring this number 5 by 5. So, it is a 2 dimension, it is telling us the variable I am using dim3, variable name is blocks 3d and I am passing 3 values to this variable. So, that means it is telling me that this is a 3 dimensional. So, when I am declaring like 5 here, so you can say I can show you like this is a 5 dots, you can say. When I am talking 5 by 5, you can say that is a 5 matrix here. matrix of 5 by 5. When I am talking about 5 comma 5 comma 5, you can say one more layer is added in a z direction. What is the advantage of 2D, 3D and 4D vector types in CUDA? So, first is a compact representation it gives, and second it improve the performance by storing the values related to the one particular object in a collaged manner. So, memory can access efficiently. It provides a simplicity to code, meaning is that instead of declaring the multiple variables, suppose in 3D case we have to define 3 variables. Instead of defining 3 variables, I can declare only one variable and I can keep the all values related to that particular object. So, it is giving you the simplicity to code, that means it is easier to read and maintain. When data related to the object is efficiently arranged, so the mathematical computations that is being performed on that particular object's values, it will be more efficient and it can be parallelized effectively on the GPUs. Last one is giving you the flexibility. It basically it is allowing the developer to choose the most suitable data type for their application, whether they are dealing with 1D vector problem, whether they are dealing with 2D vector problem or whether they are dealing with 3D vector problem. So, ultimately it is giving the advantage of that it is optimizing both memory uses by improving the access and the performance by improving the mathematical computations on the object's values. Thank you.